session, in the second forest resource session at 10:30 to 12:10. But as I said, we use also Farsight to model the fire spread, and the line of the fire intensity, and well, it's crucial that we have an accurate information about the modeling of fire. For this reason, we had to assess that accurately. We try to use a custom fuel model. We try to use let's say a special wind model. It was expensive to use some others, difficult also, but we use Wind Ninja model, let's say, to simulate the wind issue. Now, these are the objectives. So the objectives are to simulate forest fire spread and to evaluate the effect of using uniform wind and spatially varying wind data in explaining fire spread, and to validate Farsight simulated burned area. We have historical data from 2008, and then we use 20, 26, and 28 April, small areas where where fire happened, and then we check that with the Farsight. And then we evaluate with the idea that to evaluate the distribution of fire intensity, and then to model and map carbon emitted from forest fire for April 2005. This is the area, the study area actually, and you can see this is Nepal, and Nepal is in the northeast part of India, and Kathmandu is somewhere around here. So this is Gorkha area, east, you can say east and a bit north of Kathmandu. The area is actually divided, the forest in the area is divided between lots of community forestry group and then some government forest. Some of the characteristics of the area, some of the data that we have used to run the model and also to evaluate the model. We use also a lot of data from ACRS, and they are our partner in this project. The project was after red and carbon estimates funded by NORAD. The first part in the method was concentrating on GOIs and classification of GOIs to come up with the forest cover map, and the second part was on the issue on the let's say on the data collection and the use of allometric equation to assess the biomass. The third part was to collect the weather data and to assess the gridded wind data and compare it with the uniform one. And then the fourth part was to run the Farsight model, and this is all the part of Farsight. Then after that was to assess the accuracy of fire spread, and with the fire scars maps that we had from the data that had before, and then after that the last part was to do the kriging and then assessing the above ground biomass and carbon map, and then that was before, and then the last one was to model the carbon map. Now, these are some of the forest cover type maps and the areas, and then also the amount of carbon on average in different type of forest. These are example of these forests. A lot of sal and other type of forest. The overall accuracy of the classification was 84, kappa was 0.8, 3 different classes. This is the simulation of 20th of April, and then you can see here that when we use the gridded wind model, Ninja model, it was better than the uniform. For the 26th also, and then for the 28th of April. These are pieces of areas where the fire happened, and we use it to assess. Now, for research questions and answer to these research questions, the use of spatially varying wind data significantly explain fire spread model accurately than the use of spatially uniform wind, and the far side reasonably accurate in terms of the spread of the model with the fire scars when you compare it, and how is the fire line intensity distributed in these 3 areas, and then the amount of area was or the area was burned. So high fire intensity in the low density forest, while the shrub show high intensity fire. Both low density forest and high density forest had high fire intensity. But as I said, medium is here. We have the fire intensity map in the 3, 20, 26, and 28 fire. The coarse pixels is because the far side has far side has 30-meter resolution, so we had to actually coarse it. This is the carbon stock map of the area, and this is the model, the modeling of fire map, and this is showing the amount of carbon emitted from each of these forests in different, let's say, fire, and in different cover types. This is the fire carbon emission. As I said, it is coarse because of the 30-meter resolution of the far side, and these are some of the conclusion in which we think it was the modeling was reasonable. However, we were, as I said in the beginning, we were not after the validation, but more to develop a method to see that we can model the carbon emitted from fire. But yeah, validation is needed, and some other further study we need to work on. As I said, we have already did some improvement by going to the level of pixel instead of having an average situation compared to the work that we've done 2 years ago in Ghana, but further fine-tuning of the model and improving the result is still needed. Thank you very much.
Now is the question time. Do you have any question? Do anybody has any question or any comment? No? Well, if you have any question or detail, you can discuss with Jim.
Sure.
Okay.
All right.
Now, let's thank you for this question.
Thank you very much.
The next paper is hazard removed for high-resolution satellite image. Let's welcome Li Yu Zhang.